Hello and welcome back to another morning of Streaming School. Thank you so much for joining us again. I hope you enjoyed the media lesson first thing. And now we're lucky enough to have Bucky Yusuf with us to teach us another, or to take us through another period of science. Very good morning to Bucky.
Good morning, Leon. Good morning, everyone. It's good to be back.
How are you?
Yeah, I'm good. It's the start of the last week before we have half term, so I'm glad that we are going to have a bit of a half term break for my school, that is. So yeah, just taking the Monday morning slowly and seeing how the week turns out.
Brilliant. Well, thank you so much for joining us again. It is now on your screen, so please, the floor is yours.
All right, thank you so much. Okay, so welcome everyone to another session of chemistry. Those of you that have joined me before will be familiar with the quickfire 5, just 5 very short, five quick ways of reviewing some of the things that we've actually covered so far in chemistry. And all you need to do, basically, in your exercise book, or your device, on a piece of paper, is just to write down numbers 1 to 5 and to jot down a one-word or short sentence answer for each of these questions. Now, if you're watching this in your own time, please pause at this point for about 3 minutes and quickly jot down your answers. Those of you that are with me live, let's just quickly go through what the answers are. So, number 1, what is the AR of nitrogen? If you're not familiar with the term AR, that basically means the relative atomic mass of nitrogen, and the answer is 14. So if you look it up on the periodic table, you'll see 2 values, 7 and 14. The higher value represents the atomic mass, and that's what the answer is. Number 2, what does the word allotrope mean? Now, this links to the previous lesson I had looking at giant covalent compounds, and it means different forms of the same element. We looked at carbon, which can be found as a diamond, as graphite, as links of fullerenes shape, lots of different forms, so that's an allotrope. How can you calculate the number of neutrons in an element for number 3? And that basically means that you take the atomic number away from the atomic mass. So if you look again at nitrogen, where you've got 7 and 14, you take 7 away from 14, and that will give you the number of neutrons in an element. How many atoms are in sulfuric acid, H2SO4? All you basically do is look at each of the atoms. You have 2 hydrogens, and they count as 2 individual atoms. 4 oxygens, 4 individual, add them together to give you 7. And number 5, name one example of a giant covalent compound. If you joined me last lesson, you remember it could be diamond or graphite, for example. And if you did the homework, you should know that there are other ones as well, like silicon dioxide, etc., etc., etc. So there's quite a number of giant covalent compounds. Now, in today's lesson, we're going to be looking at aspects of quantitative chemistry. I put relative formula, mass, and percentage composition just to make it easy. So even if you do foundations here, this is something that you will need to be able to do. Towards the end of the lesson, we're going to get a little bit more challenging, more difficult with the concepts, but it still links to the theme of quantitative chemistry. So again, the do now covers some of what we've looked at beforehand. So we're recapping previous knowledge and building upon it to build your confidence. So the do now, what do the following words mean? Atomic number, atomic mass, relative formula, mass. And challenge, how could you calculate the percentage of an element of a compound? We're going to be looking at those 2 aspects in today's lesson. So with the do now answers, just highlight these values here in the elements. The atomic number basically means the number of protons or electrons in an element. The atomic mass means the number of protons and neutrons in an element, and they are represented by all the values that I've circled for fluorine, for oxygen, and sodium. And the relative formula mass, so if you've got a compound, a covalent compound, for example, you would add up the atomic mass of every single element in that compound. Now, these concepts are really key to make sure you understand, because we're going to apply those in a little bit while. So the challenge, we're going to look at that a little bit in a few moments in this lesson. So just to recap on something that we looked at beforehand, if you are given a compound, so for example, you've got methane here, CH4, you could be easily asked how many atoms are in here. And this is something that a lot of students struggle with. They may recognize that you've got carbon and hydrogen elements here, but they may not actually recognize the value of this 4 here, okay? So If we were to unpick that, it this way, carbon, you've got one carbon atom. I've represented it by red to make it visually clear to see. And because there are 4 hydrogen atoms, I've represented as 4 blue hydrogens. And that basically means that you have got 5 atoms in that element. Now, if we were to work out the relative formula mass, you have to add up the atomic mass of all of the elements that you actually have. And that basically gives you a value of 12 when you add them all up together. So it's as straightforward as that. If this is something you find difficult, please practice this in your own time and look at examples you can find on the internet that will help you build your confidence and your skills so you get the correct answers. Okay, so progress check, quick progress check here. Same application of information. What are the total numbers of atoms in the following compounds, and how would you work out their relative formula mass? So you've got sodium hydroxide, water, and calcium hydroxide as well. So NaOH, how many atoms? You should recognize that you've got 1 sodium, 1 oxygen, 1 hydrogen, 3 atoms. You add up their relative formula masses to give you a value of 40. Now, we have done this before, so this is just an opportunity to practice this and really make sure that you understand it. It's really key for what we're going to be doing later on in this lesson. What about the same with water? How many atoms have you got? The 2 is next to the hydrogen, so there are 2 hydrogen atoms, and there's an oxygen there, so there are 3 atoms. Add up their relative atomic masses, give you a value of 18. Calcium hydroxide is a little bit more challenging because you've got the OH, the hydroxide, in brackets. Now imagine the brackets are like a bag. So in the bag, so the value out here tells you how many items you've got inside the bag. So there are a lot more atoms here than we've seen beforehand. So you've got calcium, and it's represented by its atomic mass of 40. Inside the bag, you've got 1 oxygen and a hydrogen. The atomic masses, but you've got 2 of those, hence why we've got those 2 in brackets, and that gives you a total of 74. Again, if you find this challenging, please recap this in your own time. Okay, now moving it up a little bit to look at our challenge question in the Do Now activity. So here's a question for you. How would you calculate the percentage in a test if you got 21 marks out of 28 questions? What would you do there? Now, a lot of you would know that you'd have the 21 over 28. You times it by 100, because it's percent for every 100, to give you that value as a percentage, 75%. When we look at calculating the percentage of an element in a compound, it is a similar principle. Okay, so this is the formula. The percentage of an element in a compound. N would actually tell you, we'll look at N in a moment, actually, to integrate context. AR basically gives you the relative atomic mass of the element you're actually looking for. MR is a shorthand way of writing relative formula mass. So if you're familiar with chemistry, you may be familiar with these terms already. If not, just write down what you're used to. Atomic mass and relative formula mass, and times it by 100. Right. So N tells you a number of atoms. Again, we look at it in the context and what that actually means. So this is a little bit, forgive the PowerPoint layout, it's a little bit strange. So we're going to look at calculating the percentage of sodium, Na, in this compound, sodium oxide, Na2O. This is the formula that you will always use. The percentage of the element is your number of moles of the atomic mass, relative formula times 100. Okay? So if you look at this compound, this 2 is next to the sodium. Basically means that there are 2 sodium atoms. You put that here. That's what the N stands for, okay? You may find sometimes that you won't have to use N at all. So if there's only 1 atom, then obviously N will be 1, and you could actually miss it out. But for the purpose of the example, we put 2. You then work out the atomic relative atomic mass of sodium, which is 23, and you put it over the total of the relative formula mass. And what I've done here in this orange box is showing you how you work it out. So you times 23 for the sodium, plus the 16 for the oxygen, which gives you 62. And then you just times it by 100 to give you a value of 74.19, or 74% if we're actually rounding it up. Now that's a lot of explanations there. And again, please make sure that you cover this in your own time if you find it a little bit confusing. So let's give you a chance to apply your own learning. Now, what I've done here is, to make it quick, is I've given you the values for the relative atomic mass of the elements that are in these three examples here: the magnesium, oxygen, sodium, hydrogen, and nitrogen. And I'd like you to try these three examples. The stars indicate which one, how easy they are. So obviously 1 star is relatively easy, 2 stars a little bit more challenging, and 3 stars the most challenging of all. For the sake of this, we're going to go through 3. And if you're watching in your own time, pause for about 5 minutes here. You actually have the time to work through your answers correctly. Those of you with me, we're going to go through the answers right now. So this is the answer, 60%. And what I've done is I've just indicated why. So you've got the relative atomic mass of magnesium here, 24, divided by the relative formula mass of the whole compound times by 100. That's straightforward there. Same thing, we've calculated the percentage of sodium in sodium nitrate. You've got the relative atomic mass of sodium here, 23, divided by the relative formula mass of the whole compound, 85 times by 100, which gives you 27.1%. And the last example here, where you're asked to find the percentage of sodium in sodium sulfate, you have the relative formula mass of sodium. Now, it's 23, just to remind you, because there are 2 atoms of the sodium here. And you divide it by the relative formula mass of sodium nitrate, sodium sulfate, to give you a value of 32.4. I know some people, when it comes to, say, like calculating numbers, gets a little bit tricky. Please go through this again in your own time if you find that to be the case. Now we're going to take it up a little bit more challenging and look at how we can calculate moles. Okay, this is the formula that you actually use that links the mass of a compound with its relative formula mass and the number of moles. We're going to see how you can apply that. Excuse me. So, with GCSE chemistry, if you're ever given a question about moles, calculating moles, there are 2 possible calculations you can actually look at. You may be asked to calculate the number of moles, or you may be asked to calculate the mass. Okay, so they're the 2 aspects that you would actually look at. Now, let's just look at, excuse me, how we could actually apply that. Now, the visual that you saw before, let's quickly go back. This visual, it's a visual representation of this equation here. The number of moles equals the mass divided by the MR, the relative atomic mass. Okay, so 2 examples. You're asked to calculate the number of moles in 470 grams of K2O, potassium oxide. On the right-hand side, you're asked to calculate the mass of 4 moles of K2O, calcium oxide. Potassium oxide, forgive me, so calcium is potassium oxide. So if we look at the left-hand side, the relative formula mass of potassium oxide is 94, but you've got 2 atoms of potassium and oxygen here. You use the equation, the number of moles equals the mass divided by the relative formula mass. And that basically means 470 grams that they've given you in the question, divided by the relative formula mass 94, which basically means you have 5 moles of potassium oxide here. If we look at rearranging that equation to work out the mass of 4 moles of K2O, you've got this. Again, the relative formula mass of K2O is the same, it's 94, always will be the same. If you rearrange the equation, so this time the mass equals the number of moles times the relative formula mass, that gives you this, 4 times 94, and that means that you have 376 grams. And they basically are the key principles for any questions involving moles. How do you feel with this? We're going to take it up just a little bit more, and some of you may be thinking, oh my goodness, I don't get it. And if that is the case, pause here, go back to the beginning of the video and watch it again in your own time. Let's just take it a little bit more challenging with this example. So aluminium is extracted for aluminium oxide as shown in this equation. Got 2 lots of aluminium oxide, which goes to 4 lots of Al, aluminium, and 3 lots of oxygen. And you are asked to calculate the mass of aluminium that can be formed from 1,020 grams of aluminium oxide. Okay, so how can you do that? This is another representation of the equation I showed you before. The number of moles equals the mass over the relative formula mass. And this is us applying it now. It may seem, oh my goodness, there's lots of information. So let's break it down. On the left-hand side, aluminium oxide they've given you. What is the relative formula mass of this? Okay, 54 plus 48, which gives you 102 grams. How would you use this to help you work out the number of moles? So you've got the mass that was given to you in the question, 1,020 grams divided by the relative formula mass, 102 that you've calculated on this side, on the left-hand side, and that gives you 10 moles of aluminium. So even if you find the question really challenging and you can work out the number of moles, you will still score some marks, which will demonstrate to the examiner that you understand some of the principles. Then what we'll do, so you've got this. So going back to the equation that was given on the previous slide, 2 moles of aluminium oxide would actually give you 4 moles of aluminium. That was from the equation we saw when you balance the number of when you balance the number of atoms that actually were given there. Okay, so 10 moles of aluminium oxide will therefore give you 10 divided by 2, dividing it by 2 here, of 4 moles. I hope my explanation is clear, because I can understand it will be like, oh my goodness, really confusing here. But then when you convert this to mass, 5 times 4 is 20, it gives you this. And I'm going to pause at this point, because you might be thinking, oh my goodness, we're going to recap this again next lesson and actually extend it to part of the homework I've actually given you. If you understand this at this point, have a go at these 2 questions here. Part A, where you're asked to demonstrate the mass of a product that will form from the metal that's given here, iron. And part B, where you're asked to calculate the number of grams of the non-metal when it reacts with 5 grams of metal here. Okay? If you're working this out in your own time, again, give yourself 5 minutes so you can actually show you're working out the correct answer. If you're with me now, I'm only going to show you the answer rather than explain. And the reason is because I'm going to cover this in more detail next lesson with you. So, answers. Okay? Quite challenging, and even my mind has got a little bit hot thinking about this, but really key calculations. Quantitative chemistry is a great subject, but one I know that many students actually struggle with because of the math involved. And that's why we're going to break this down into 2 sections and continue with it next lesson. So how did you get on and what are you struggling with? And that leads us to our review for today. So what are the 3 things that you're going to remember from today's session? Which 2 aspects are you still struggling with? And if you're finding that you've got more than 2, that is okay. That is natural. That is what a lot of people, students actually struggle with. And we're going to recap this next time. And what is one thing that will actually help you tomorrow? So in preparation of the next session, which you're going to have maybe next week, Monday, there are 2 videos I'd like you to do as part of your further thinking. The reacting masses video. So if you look at this, if you can actually look on YouTube for the GCSE Science Chemistry 9-1 reacting masses, this guy represents the video site, free science lessons. He's really good. So we'll talk you through that. And also the next slide, the next video of how to concentrate, how you can work out the concentration of solutions. A lot of talking today, a lot of calculations, but you're happy to know that is the end for today. Thank you very much for actually taking some time to watch, and take care. Bye-bye.
Thank you so much, Bucky. Really, really appreciate it. What does the rest of the day find you doing?
Well, I'm going to be coaching actually. So I'm going to be coaching some colleagues and school educators this afternoon. So preparing for that. I love coaching as well. So one of my other skills, on top of everything else that I do, is I'm a qualified coach. So it's always great to have an opportunity to do that. And yes, just get some of my admin and preparation done for my own lessons tomorrow and on Wednesday. Yeah, quite a busy day today.
Wonderful, wonderful, wonderful. Well, thank you very much again for helping us, and really look forward to picking up with you sooner rather than later.
Okay, you take care as well. Take care, Liam. Take care, Nisha. Bye-bye.
All yours, Nish. And you're on mute, Nish.
I mean, this would be great to practice lip reading, right? If you need it in life, who knows? So the task for chemistry today is how can you calculate the concentration of a solution? Hopefully you can get that from Bucky's video. If you want to catch up on any of the previous videos, you can find them on Facebook and on YouTube, and also on the Streaming School website. Are you still there?
You finished, Nish?
Yeah, that's it for today.
Sorry, delivery came. Sorry, everyone. Delivery came, and Layla was going to take over Streaming School for a short period of time.
I
So
sat in your chair.
she sat in my chair. She sat in my chair. That's very. Is that cheeky? Yeah.
What did she say?
It stinks. I sat in your chair and it stinks.
Oh, God.
So Layla moved through and through. Sometimes I think I should just end up streaming just me and Layla, just doing his cheekiness.
I mean,
all right,
staining.
I'll see you. Catch you in a bit, my dear.
Yeah.